Okay, well, we just had two really good offline discussions about costing energy. Joseph wanted to know why propane was more expensive, and my general answer, I don't know all the reasons, but my speculation would be that based on what we know about the distillation process, methane's the lightest molecule, it's coming off the top, and so in a lot of ways it's sort of the simplest and most predictable to make. Your ethane, which is 2 carbons, your propane, which is 3, your butane, which is 4. They're not as high a demand for them, and they're sort of half. They're just little mid-sized marbles in that big marble stack of molecules coming off the top. Also, the fact that there's no grid scale propane delivery like there's natural gas forces us to do a lot of storage. You'll see that in that storage isn't free. And a lot of transportation, obviously, that isn't free. So I think that's the reason propane's more expensive. Slightly more esoteric to make, storage, transportation. And then, Todd, you just brought up the PV array, and the friend of yours who said, okay, $3 savings on a $700 bill just isn't worth my while, but it would be to me. It would be.
It was $3.75 a month, right? So you're looking at more like $45, $50 a year savings over the course that it takes to pay off the $700 buy-in.
Yeah, another question too on these community solar projects. And let's say you and 50 other families or groups go in to put this thing in. Typically, that is more cost effective. Just putting one large system is the same thing, economy of scale. It's better to have one coal-fired power plant than having one in every single person's house making electricity. So putting in one large community scale is more cost effective because there's less wires, less permitting, less whose roof is which angle, et cetera, less manpower going in ahead of time. But the question is, if you move, who then owns that electricity? I guess it seems like if you were still in the same utility somewhere, like if you were still a Northwestern Energy ratepayer and that primary energy source was on, then you would still own it and take advantage of it at your new residence, and somebody moving into your residence that didn't actually own the panels themselves would not have it. I mean, you still own it. If you left the state, though, maybe you just sell it to somebody else. Sell it to somebody else who was not in on the initial investment, but who wanted to be, and then they buy you out for whatever it's worth, and then reap the benefits over time. Great discussions on costing, though. Okay, next couple figures, inflation, and that's why it was not all that clear on this figure, whether these were constant dollars or inflated dollars, because as time progresses, dollars and any currency typically lose value. You could not buy as much now with a dollar that you used to be able to. And that's what this 12.3 is all about. So what the authors are showing now in figure 12.4, it says a sample batch of everyday household items. It is these and a few others that enable the real value of money to be measured. So if you remember back to my summary one, I was looking at the cost of I was looking at the energy density of coal, oil, natural gas, geothermal, et cetera, et cetera. I even looked at the energy density of food. I mean, everything we see in this basket here is either a carbohydrate, a protein, or a fat of some type. I'm not sure what's in the mustard. Mostly. Well, there's some oil in the mustard usually.
A lot of yellow number 2.
Some coloring, some flavoring. Not a heck of a lot of calories, I guess, to power you through your day. But something like this basket of food represents real value. I might have mentioned this previously in class. And if you get a chance, I would recommend this author. I've read this book a couple times and handed it to a friend of mine, The Origin of Wealth by Beinhocker. Came out in 2007. Yeah, so if you get a chance, pick this guy up. It might make for some nice holiday reading. One thing he goes through and talks about the origin of money in various societies. One thing I found fascinating was that there were Phoenician bankers keeping track of how many sheep different landowners had, because that sheep was your primary status symbol, wealth symbol, etc. And so they would take little ball, there'd be a ball of clay for each sheep, and so make these little balls, put the balls in a jar, seal the jar, tamper-proof, so you could remember. In a lot of ways, it was a computer too. That was the digitization of goods and services back in the day. They'd seal the jar, stick it on the shelf, and then that was their accounting system. How many sheep does Bob have? How many does Joe have over here? And then when the society grew, they sort of started running out of jars and running out of shelves, and I guess another part of it was they would have to, in order to count the balls, they would have to break open the jar, and that was cost time and effort, etc. So they started just taking sheets of paper, or papyrus, whatever you call it back then, and sort of sticking it to the front of the jar so that you didn't have to open it up to see how much was in it. And so eventually they didn't open the jars at all, and they kind of forgot the jars were there, and they just ended up with a big stack of notes on the front of the jars, and that became the money. It was like the first invention of paper money. So, it's like, see, I got it. And it's kind of the same thing with our own currency. It's just something, it's an agreed to artifice. It's telling you how much you have of money, whatever that is. And so it's a human convention. It's currency, and it's just agreed to. It's not that. It's not your breakfast, lunch, and dinner that keeps you alive. So. So the next little figure, this is called the retail price index, and I'm just going to read from the book because I am not very good at explaining this. The retail price index, RPI, is an economic indicator that specifically addresses the prices of a representative mixture of typical goods. I guess we were looking at the goods a second ago. It says specifically excludes any interest payment such as on mortgage, etc. So it's not including the price of money. So money itself also has a price. If you go to get a loan from the bank, they might give you the money now, but they're going to want more back later, and they're going to want more back than inflation would indicate. They're going to want to earn money back at a rate than background inflation. It's also kind of why our mortgage rates are as low as they are right now. With the Fed having the interest rate pegged pretty dang close to zero, banks can afford to give you relatively low interest rates. If the Fed had it higher, then banks would have to go even higher so that they could, keep the lights on, keep the tellers paid, and all that good stuff. So, and the scale you'll notice here on the left, it's actually a logarithmic scale. So we're going back to 1950, and I hope, it doesn't say this, but I hope that the line that they're showing here contains the same set of goods, the same set of goods that keep us alive and healthy. And they also said they normalize it, base it on 100 in a specific base year. So we're just going back to 1910. So 2010. You go back to 1950, and right there around 2, 4, just below 5, $4 or so. So things have more or less become 20 times more expensive. Well, how did that happen? If we take a look at the graph on the right, you can see that the inflation rate itself changes. Never quite goes negative, kind of dips pretty low there in 2008. But and I think it must be, 1975, inflation rate 25%. So, is that a bad thing? Well, it says right here in the book, there's been a 27-fold increases in prices in the UK, as we saw there in A. But for most people, this does not involve social hardship because the wages go up, right? So, the prices of things go up, and so do your salary, hopefully. And I don't know that the book talks about this very much, but there are two different types of poverty that economists discuss. One's called absolute poverty. Absolute poverty is when you don't make enough money to do that. You don't make enough money to sustain and survive and feed yourself. Relative poverty is when you can't afford a new paint job for your Ferrari when your buddy next door just got one. So they're two fundamentally different types of poverty. One is like you do not have enough money to survive. The other one is where you think, woe is me, I don't have enough cash to go get an ice cream at Big Dipper, whatever. So.
Quite good separation and references.
Okay. Now, and I am not much of an economist, I'll admit, but and so I don't know all of the forces that drive inflation, but we can see when inflation gets out of control, money has to be printed quickly in order to keep pace with the apparent rises in cost. And so we see here is hyperinflation. This is 1922. German shopkeeper had to keep his money in a tea chest because there was not enough room in the cash register. So the money became so invaluable. A dollar was not enough to buy what it did several years ago. I might even say here with the. Oh yeah, this is bizarre. It's even hard to believe that there's not a typo in the book, but it says. In 1922 and 1923, inflation in Germany reached staggering proportions, peaking at 2,500% per month. So, what cost you, let's see, let's do that math. So if it was, if something cost you $1 in November, if it was 100% inflation, it would cost you $2. If it was 1,000%, it would cost you something that cost $1 in November would cost $25 in December, and then it would cost $625 in January.
Good Lord.
So, think of like a Snickers bar right now costs a big Snickers bar, but $625 for a Snickers bar 2 months from now. And so, yeah.
That beer?
Yeah.
$400. The amount of gobs of money you have to pack in your pocket just to pay for standard stuff.
Yeah, right. It's just silly. It's weird, and it's just currency too. It doesn't mean there was no. It's just a problem with currency and accounting. It's not that there's fewer items on the shelf. It's not that there's less natural resources available necessarily. It's just poor economics. In fact, if you've been listening to the news, they talk about all the economic problems happening in the Ukraine, leading to, wars and conflicts like that. A lot of the American pundits, intellectuals, economists will just blame it on the lack of brain power in their cabinet. The guys just did not figure out how to run their economy properly. Maybe it's true, maybe it's not, but it does take some pretty bright and on the ball people to keep this stuff in order.
So then you wouldn't even have strippers anymore because they'd have to have so much clothes to have it'd be worth going.
Well, you can do some fancy things with a wheelbarrow, Oh, goodness. All right. Now, this is figure 12.7. We're looking at UK real petroleum prices, 1990 to 2009. So this is a 20-year snapshot. This says it's adjusted for inflation, so it's expressed in whatever the pound was worth in 2005. I guess I thought lead was taken out of petroleum, which, oh yeah, it's just lead. There's no lead in any of this stuff. And then you've got your ultra low sulfur, and then your diesel. So they're all kind of marching along relatively steady. This gets back a little bit to Joe's question about why propane's more expensive than methane. There's a little bit of supply and demand going on here. In general, there's less demand. Well, it's a little bit backwards. Diesel is not as in high demand, so there's not as much of it around, so it kind of strangely leads to a supply problem, if you want to look at it that way. Pump prices spiked in the 2000s, spiked again in 2009 or 2008. And let's see here, 2007. Well, and they're obviously tied to oil prices. So most of what you see on the top is from tax, because it says in there were increasing concerns about pollution. So in '93, UK put a bigger tax on the tax on fuel. Then there were protests in 2000. Our fuel's too expensive. Okay, and what they do now is look even further back in time. Yeah, I like this chart a lot. With this, we're sort of looking at the three phases of matter, right? So you've got gas, liquids, and solids. If you want to call electricity a plasma, I know it's not, but maybe you're looking at all four phases of matter there on one chart. Electricity becoming way less expensive, obviously, because of the grid coming online and more efficient technologies.
When you say solid fuel, is that in reference to just burning firewood?
I think it's more coal, but and firewood might be in here too, but it's primarily going to be coal. Okay. Yeah. And then I think the only way we're going to see any of these come back down, the oil, gas, and coal prices come back down, is if there's less demand for them. You know, if in fact we put in more wind, if in fact we put in more solar, then our current extraction rates for these other fuels will be excessive. We'll have a surplus of them, and then they'll go back down. And in my mind, that's the only way it's going to happen, because they're finite. You looked at worldometers; they're going away, and usually scarcity means greater price. But if we get our act together and start insulating our houses better, using geothermal, using solar thermal, et cetera, we might see a glut in these conventional fossil fuels, which would then drive the prices back down again. So if you ever, so again, go back to worldometers, hit summary 3 again for a second.
Well, and I mean, just take a look at exactly what he just said about his friend. She found she could do it for cheaper, although the price is extremely negligible, but it could be done for the same price, and still not willing to do it, to go to something that is sustainable, that doesn't have all the bad things that come with it as what we're currently using. And it's that attitude of indifference that we also got to get over to.
Yeah. It's true. So here, 38 years till the end of oil. That's at current consumption rates. So this is just doing extrapolation. If overnight we go out and change all our cars over to electric, and all that electricity is made from sunlight and wind, then the oil could last forever, right? I mean, just stop using it; it's still there. It could last indefinitely. And I said this too in my lecture in Billings. If we do want to look at this as sort of a geoengineering problem, it might be that if we start taking a very long look at the future of the planet, it could be that, hey, let's keep the coal, the gas, the oil around, because if we do end up heading into some kind of ice age, let's spark it up again. Let's go ahead and warm the atmosphere a little bit. I mean, we're doing it unintentionally now anyway. There might come a time in our global civilization where we do need to turn up the heat a little bit.
We've seen a lot of movies about that. Is that something that, could potentially happen? I mean, of course, potentially it could, but is it something that, there's a lot of, I've been seeing a lot of papers about that, like ice encroaching on different areas and ice melting also in different areas? Well,
yeah, the thermohaline conveyor belt that keeps Northern Europe warm, there are climatological models that predict that conveyor belt. It hasn't been there forever. I mean, the planet changes constantly. I mean, we don't have Pangea around anymore. So that whole thermohaline conveyor belt's, relatively recent phenomenon. But if it shuts off, Northern Europe gets a heck of a lot colder because all that warm air from the middle Atlantic is being pumped up there.
The prices they're charging in Denmark, I wouldn't want to be there.
Yeah, so I think though, in fact, I guess since we were talking about summary 5 a little bit, it's not worth, it's not too far off base to mention this paper of mine. I'll just go ahead and show you guys right now. Maybe I will assign it. I'm not sure if it's actually going to come out this year or not, but it was finally accepted in the International Journal of Design, Nature, and Ecodynamics.
You said you don't know if it's been published yet? Or
it's been accepted. It's been accepted. I have the proof right here.
Now, accepted, that means that they're going to put it in at some point in time in their magazine, right?
Yeah, in their journal. So it's the International Journal of Design and Nature and Ecodynamics. They don't have a volume and a number on it yet, but, you know, it's 17-page paper. I just bumped into Gary Oram last night. I think Serenity is thinking of pursuing an engineering degree. Hopefully he'll come back. A lot of times I find guys that say, hey, I'm going to get my engineering, like, oh, I think it's a little safer back in energy tech back in the good old days, so hopefully we'll get him back. But I tend to, I guess what we were talking about is the fact that if we start conserving, the price of these fuels could start to drop, and their the number of days left. We were looking at this guy. The number of days left could sort of just stretch off into infinity. So what I try to do a little bit in this paper is not just look at temperature. I look at the rate at which disorder increases. So I look at the rate of entropy increase. The little dot over the S there, which is the symbol for entropy, and entropy is just joules per Kelvin, or energy per temperature. The dot just means the rate at which that's increasing, and that's just the statement of the second law of thermodynamics, where entropy is always increasing. And so my argument here in the paper is that I think I've got some figures at the end here. You guys might find this. I think some of the social scientists in the class might appreciate this. I sort of go back to foraging, agrarian, and now modern civilizations, and show that much earlier, I guess I don't write entropy per se, much earlier their, well, I've got it as energy. Their energy usage rates were smaller, obviously, than they are now. I mean, no secret there. But also that since the rate at which we extract energy from the environment is increasing, so is the rate at which we entropicize the environment, the rate at which we make the environment more disorderly. And there's not a whole lot of literature out there on that. It was just something that I found fascinating. I also, in the paper, so what I do, I'll show you two little things.
What's the word agrarian mean?
Agriculture. Just moving away from just picking a banana out of the tree to, sticking a wheat seed in the ground.
Okay.
Yeah. As populations became more dense, we were sort of forced into agrarian societies.
Okay.
This was the equation I came up with. It's a ratio between the rate at which we're entropicizing the environment and the rate at which we're informatizing the environment. Knowing things about the environment, if you will. So if you've ever seen the Google car drive past you, I mean, it's basically taking the physical world and digitizing it. It's taking all of what the car sees around it, sticking it into a computer and turning it into a bunch of code on a computer. At the same time, the Google car, in fact, I've got the Google car right there, is entropicizing the environment because it's, well, the ones I've seen anyway, well, a lot of them are Priuses, but they're burning fuel. They're doing this. They've got oxygen and octane coming in one side and greenhouse gases coming out the other. They also have a little bit of information coming in, so they've got programs telling their computers where to run, but then a lot of additional information coming out, so when their self-driving cars start working, they've got access to that more robust, enhanced amount of information. So I put that together. Here, and I sort of, in a way, say that the Google car in itself is a more sustainable technology because it's harvesting a lot of information with a relatively modest entropy footprint, if you will. Whereas the coal rolling truck with the AM tape deck not so much. You know, it's anthropocizing the environment. You know, the coal rolling itself might cause someone else to crash their car. The act of breathing that exhaust will further anthropocize the lung tissue of somebody, leading to their premature death, etc. So you could put an alpha, and this alpha is just a ratio between those two things. And then just to wrap it up here, I think since I went there, I think this is going to have to be summary 5. I think you guys will enjoy it. This is my last little coefficient. And I did mention previously that information itself, or sorry, money itself is just sort of an agreed to artifice. Like, you know, I've got money in the bank, but I don't have that many dollars in the bank. I just, you know, the bank just sort of has a little computer somewhere that has ones and zeros representing how much money I have. This little equation relates the rate at which money in someone's pocket increases as a function of how much information they have. So if you are Martha Stewart in 2000 whatever, and you have the insider information on what particular company is about to sell or buy or whatever, and you use that information, you can then have access to more money. If, gosh, I don't know, let's take another example. If you don't know the state of, I don't know, maybe your own automobile, if the computer that's monitoring the pressure in your brake lines on your computer fails, you lose access to that information, your brakes go out, you crash your car, now you're in the hospital, and now you're paying money to the doctor because you did not have the information about the state of your car. That's sort of a different realm that you don't want to be in. So that little beta that I've got there is the ratio between which you have access to information and the rate at which you are either spending or earning money. So, I don't know, it was a fun thing to write about. So, hopefully that's a good intro to costing energy. I think there might be one more figure we need to look at in 12.3. Yeah, it's just this guy. Oh, and this gets back a little bit to my comment about relative versus absolute poverty. You know, if you were spending 100% of your money on energy and you didn't have any money left over to buy food or medicine or clothing, then that would be a case of, you know, absolute poverty. In this case, most people have it pretty well off, and they're only spending, you know, 3 to 6% of their income using on their energy bill. So, and they even mentioned fuel poverty in here, I think. It's defined. It says a household is defined as being in fuel poverty if it needs to spend more than 10% of its income on energy in order to achieve a satisfactory level of comfort. That's different things to different people. All right. Well, I'll see you Thursday. We'll get into 12.4. We'll get into summary 5.
Okay, so
And I'm going to clip
I have
this.
all the information for my 3 for summary